You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hello, everybody. My name is Bob Keane. I'm the editor of the journal Fire Ecology, a journal that is supported by the Association for Fire Ecology. It is an international journal in which we accept papers on fire ecology. And today, I am pleased to say that we have a very important subject that we're going to talk about. Me being an ecological modeler and a fire modeler, I am just giddy over the fact that we're going to actually have a paper on modeling. And the paper today is Simulating Dynamic Fire Regime and Vegetation Change in Warming Siberia. We have a whole list of authors, but today we are lucky to have Neil Williams and Melissa Lucash here talk about this paper. Neil, why don't you go ahead and introduce yourself?
Thanks, Bob. My name is Neil Williams. I'm currently an ORISE postdoctoral research forester with the Rocky Mountain Research Station of the U.S. Forest Service. But for the work we're talking about today, I was a postdoc at the University of Oregon.
And Melissa?
Sure, thanks, Bob. My name is Melissa Lucash. I am a research assistant professor of geography and environmental studies at the University of Oregon.
Wonderful. Thank you, too, for coming. Afi really appreciates it, and especially me, I really appreciate it. Let's talk about the paper. Neil, give us the short and sweet on what the paper is all about.
Sure, thanks, Bob. So Siberia contains the world's largest tracts of contiguous boreal forest, and fire and climate are the primary forces that structure these forest communities across the landscape. And at present, various species of larch, which are really tolerant of fire and extremely tolerant of cold temperatures, they dominate forests across large areas of Siberia. But empirical evidence suggests that, as in many areas of the world, that climate change is already increasing fire activity across Siberia. And there's a real shortage, surprisingly, of quantitative estimates of the possible effects of climate change on fire regimes in the region, and then the implications for vegetation. So our study looks to fill some of this gap by examining the influence of different magnitudes of climate change on fire regime characteristics, and then considering the implications of this and of warming for forest communities across a fairly large latitudinal gradient in central Siberia from about 55 degrees north all the way up to 65 degrees north. So we cover a fair range of geography here.
That's really interesting. So, Melissa, why did you write this paper? What caused you to go ahead and conduct this study?
Yeah, this paper is part of a large NSF Arctic grant, and the goal of that was to estimate the ability of boreal forests to adapt to climate change, right? Basically, how well can trees, shrubs, and Arctic grasses migrate to keep pace with the changes in our climate? And boreal forests have long been a passion of mine. I like to work a lot in Alaska. And so when a collaborator of mine and a co-author in the paper, Eric Gustafson, approached me about working with Anatoly Shvadenko and Dmitry Shapashenko, some of the world's foremost experts on Siberian forests who work at IAZA in Austria, I jumped at the chance. Anatoly's a Nobel Prize winning scientist. And so I was excited to get to work with Anatoly and Dmitry as well. And our NSF project explores many different disturbances, but for this paper, we wanted to just kind of start with the centrally important disturbance in this area, fire in isolation. And we know that treating fire in isolation is kind of an abstraction of the way that boreal forests work, but kind of often helpful to simplify reality before building up to the bigger picture, which is what we're going to do in upcoming papers. And kind of the final important reason for writing this paper is that it provided an opportunity to introduce this new fire extension, BFOLDS version 2.1 for the Landis simulation model. And Landis is this really great modular forest landscape simulator that allows for sort of plug and play different modules and extensions, and they're suited to really specific tasks. So BFOLDS is this new Landis extension, and it's been used in Canadian forests, but here we wanted to use it for addressing questions related to climate change in Siberia. And we think it's a really important tool because it doesn't make as many assumptions about fire regime attributes. The fire regime emerges as a result of the simulated fire behavior produced by the interaction of weather and fuels and topography that we know are really important in these systems.
Okay, now you're talking my language. I am just excited to hear about the methods that you use to conduct this simulation experiment. Neil, do you want to go into the methods?
Yeah, so we took 3 different study landscapes, which were located across this broad gradient in latitude in central Siberia, and then looked at 4 different climate scenarios, 1 contemporary climate, and then progressively more extreme warming. And then we used Landis to use the Beefolds fire extension that Melissa described with peanut succession extension for vegetation. This is this really intricate process model that allows us to simulate fire activity and forest dynamics. And we did this during the 21st century in each of the study landscapes. And then using the simulation outputs, we calculated a bunch of different fire regime characteristics from the number of fires per year, burned area, fire size distribution, fire rotation, and so on. And then we analyzed changes in vegetation from the perspective of the fire life history strategies that our plants employ to survive in fire-prone environments. And to do this, we grouped the species with similar life history strategies into what we term in the paper fire response groups. For example, fire resistors, which are larch and Scots pine in this paper, and fire endurers, which in our study landscape were deciduous hardwood species like birch and aspen. So we looked at temporal changes in the importance of these fire response groups in each simulation landscape. And by importance, I mean the contribution that these groups make to the overall forest structure based on biomass and abundance.
Great. So, Melissa, what are the results and why are these results important to Siberia and the greater modeling community?
Yeah, this paper, we feel, helps fill a pretty glaring absence of quantitative estimates of the potential impact of different magnitudes of climate change. And our results suggest that we can't simply assume that avoiding extreme climate change will be sufficient to avert these major changes in the boreal forests of Siberia. So empirical studies indicate that climate warming is enabling this expansion of vegetation poleward into higher latitudes. But our simulations suggest that even mild warming can lead to major increases in fire activity, and that these can really counteract the benefits of range expansion, particularly in these northern boreal forests. And then our results also suggest that these changes in composition under climate change in Siberia may sort of parallel the changes that people have documented in Alaska, this shift from conifer dominance to hardwood dominance. And when we think about central Siberian forests, we know that larch is sort of this cornerstone species. And our results suggest that there might be this potential for major replacement of larch by deciduous species like birch and aspen, particularly in the kind of mid and southern Siberia. And the mechanisms are different than what we show in Alaska, but the ultimate result and trajectory might be really similar. And, you know, it's really hard to understate how big a change this would be from these boreal coniferous forests in Siberia to shift to hardwood dominance.
Wow, that's really interesting. You know, it's amazing that the model can pick that up. Well, with any models, there's always caveats, assumptions, and admissions of guilt on what they did in order to get it. So, Neil, do you want to go into these caveats?
Yeah, as you say, there's always a few caveats with any simulation model. And one of them we sort of already touched on earlier is that really we're just examining one disturbance here, albeit a very important disturbance. But we know in reality that there are these complex interactions between disturbances, particularly things like in Siberia, the Siberian silk moth, and anthropogenic disturbances like harvesting. So our paper provides the fire component of these changes, but we know that the reality will be slightly more complex. And then from a modeling perspective, the simulation model that we used is extremely advanced in its capacity to simulate different post-fire regeneration mechanisms, including resprouting and serotiny and so on. But it doesn't yet incorporate the effects of fire on soils. And we do know that seedbed conditions are also quite important in terms of post-fire dynamics. And then finally, there still is, and at the time when we developed this study, there was a real shortage of downscaled climate projections from the latest generation of GCMs that are being used in the current IPCC reporting. And as a result, the climate data inputs that we used in the simulations were just a little bit coarser than we really would have liked, and also coarser than would be ideal for maximizing these really dynamic simulation capabilities that bfolds and Landis 2 provide. So that's something for future work.
Well, those don't seem too bad. Those look pretty good assumptions. Let's end this podcast with Melissa telling us if there's any funders and recognizing all of the other co-authors in this paper.
Yeah, our work was funded by the National Science Foundation, the Office of Polar Programs, and our additional co-authors were Mark Olette, Tom Brussel, Eric Gustafson, Shelby Weiss, Brian Sturdivant, Dmitry Shepashenko, and Anatoly Shvedenko.
Well, I would like to thank both of you for an exciting summary of this paper. I hope people go out and read it as an ecological modeler. I am just so excited that we were able to talk about modeling today. It really made my day. So thank you both.
Thanks, Bob. We always like to talk about modeling.
Yeah, thank you, Bob. It's great to be on.
And thank you, listeners, for listening to Fire Ecology Chats. And I'd like you to invite you back to our next podcast. Goodbye.